Today's lesson is called Geometric Sequences. Please start with the opening exercise. You will look at sequence A and sequence B and compare the sequences. Underneath, write similarities and differences. At this time, pause the video, and when you're ready to go over the answers, you can resume. Okay, so for the opening exercise in sequence A, if I take a look at it, I see that this is going down 11 each time between the terms. So I used an explicit formula, and I did use function notation. You can use a sub n notation if you'd like. And I have the first term is 99 plus n minus 1 times the common difference of negative 11 for n is greater than or equal to 1. If you wanted to simplify that, you could. So I'll put or f of n equals 110 minus 11n. That's what you would have gotten. Now, if you look at sequence B, and I look for the pattern, here there's not a plus pattern. I see a times 2 pattern. So if you think back to our integer sequences that we did earlier, this would be f of n is equal to the 2 to the n minus 1. So similarities, they're both sequences. They are sequences. So they both fit that criteria. However, the difference is A increases by 11 and sequence B is multiplied by 2. Or some people might word it as powers of 2. So today we're going to talk about geometric sequences, and I want you to think multiply. A pattern where the change between consecutive terms is a constant ratio. That ratio is called a common ratio. So very similar to arithmetic where it's a plus, you're going to think add and it's a common difference. Here, geometric, we're going to think multiply, it's a common ratio. Are any of the sequences above geometric sequences? So if we take a look up above, do we have a multiply pattern going on anywhere? Yes, we do. It is sequence B. This ratio can be found by dividing any term by its previous term. So, for example, if I wanted to know what the common ratio was of the sequence above, I could take the, let's say, the third term, which was 4, and divide it by the previous term, which would be the second term, which was 2. And if I reduce that, I get 2. So that means that my common ratio for sequence B was a 2. So what is the formula that would represent sequence B? We had up above, f of n equals 2 to the n minus 1. And if it helps, you can make a little table like we've done in the past. The first term is 1, the second term is 2, the third term is 4. So now you can see why we need that n minus 1. If we had just had n, 2 to the first would be 2, and I'd have a 2 across from the 1. I do not. So since the first term is 1, I have to compensate for that by having the n minus 1. Example 1, Thomas sends out an email to 5 friends. If each of these friends sends the same email to 5 different friends, therefore 25 emails are sent. In turn, if each of the 25 friends send out the same email to 5 more friends, 125 emails are generated. What does this sequence look like? So we will write it down in order. We had 5, then 25, then 125, and it's going to continue in that pattern. So if I wanted to find the common ratio, I'll use the second term, doesn't matter which term you pick, as long as you have a term before it. So I'll put the second term over the first term to see that I have a common ratio of 5. So we are going to find the formula as a function for the nth value of the sequence. Now there is a formula, an explicit formula, so we'll write that down. And know that it is on the reference sheet that you would get for your Regents exam. So is the arithmetic formula. The generic formula is a sub n equals a sub 1 times r to the n minus 1. So this is the first term. This is the common ratio. And then the n minus 1 and the a sub n stays what they are. So if I was going to write it for this particular example with the emails, I've had a sub n equals My first term is a 5. My common ratio is a 5. And then I would have n minus 1 for n is greater than or equal to 1. And we can add that over here as well. For n is greater than or equal to 1. So I just want to have some practice time for you. Compare the following sequences. Determine if the sequence is arithmetic, geometric, or neither. Explain your answer. If it is arithmetic or geometric, write the equation to represent the sequence. So at this time, pause the video and try the practice problems on your own. When you're ready to go over the answers with me, you can resume the video. All right, in number 1, these are actually being divided by 5. So that's the same thing as multiplying by 1/5. So now I see that this is a geometric sequence because of the multiplication pattern. It has a common ratio then of 1/5. And if I wanted to write my formula, I'd have a sub n equals, the first term is 200, my common ratio is 1/5, and I'd have n minus 1. For number 2, if I check for a plus pattern, I've got plus 2, but then I've got plus 12, so it's not arithmetic. And if I check for a times pattern, times 2, but then this is times 4. So I don't have either one. So this answer is neither. It's not arithmetic nor geometric, therefore I cannot write a formula. In number 3, I have a plus 3 pattern, which makes this an arithmetic sequence. That means it has a common difference of 3. And my formula would be a sub n equals, the first term is -6. I do plus 1 times n minus 1, and then my common difference is a 3. Number 4, I have a pattern of timesing by -1. So this is a geometric sequence, which means it has a common ratio of -1. And my formula would be a sub n equals, the first term is 1, my common ratio is 1 to the n minus 1. Now for all of these, you should have for n is greater than or equal to 1. And that concludes your lesson on geometric sequences.